Have you ever wondered how the tiniest particles in the universe shape our world in unimaginable ways? Welcome to the fascinating realm of quantum physics, where we explore the world of particles so small, they are beyond our direct perception. These particles, our universe's building blocks, are the unseen forces that create the tangible world we experience daily. Quantum physics is a century-old science, birthed from the brilliant minds of the early 20th century. One such mind was Max Planck, whose work in black-body radiation led to the birth of quantum theory. Another was Albert Einstein, whose photoelectric effect further illuminated the quantum world. These pioneers paved the way for an understanding of the universe that continues to baffle scientists and laypeople alike. These tiny particles existing in multiple states simultaneously, interacting with each other at a distance, defy our everyday comprehension of reality. So how exactly do these minuscule particles make such a massive impact on our world? Let's dive deeper. To understand the impact of these tiny particles, we need to unwrap the complex world of quantum physics. Let's start with quantum entanglement. Picture two dance partners moving in perfect harmony. No matter how far apart they are, if one spins, the other spins too. That's quantum entanglement. Two particles light years away can be entangled in such a way that if you change the state of one, the other changes instantaneously. It's like magic, but it's science. Next up is superposition. Let's use a coin toss as our metaphor. When you flip a coin, it's either going to be heads or tails, right? But here's the quantum twist. While the coin is flipping, it's actually both heads and tails at the same time. It's only when you catch it, when you observe it, that it becomes one or the other. That's superposition. Until a quantum system is observed, it exists in multiple states simultaneously. Finally, let's talk about wave-particle duality. You know how light can behave as both a particle and a wave? It's kind of like being a world-class athlete and a renowned musician at the same time. One moment you're sprinting down the track, the next you're performing a concert. Light and other quantum particles have this dual nature. They can be particles localized in space, or they can spread out and interfere with each other like waves. It's all dependent on how we choose to observe them. Quantum physics may seem like a realm of impossibilities and paradoxes, but it's actually the fundamental laws of nature at the smallest scales. These strange behaviors aren't just quirks. They're intrinsic to the nature of our universe, shaping everything from the tiniest atoms to the largest galaxies. Now that we've scratched the surface of quantum physics, we can start exploring how these tiny particles change our world. So, how do these tiny particles that abide by the rules of quantum physics change our world? Let's consider for a moment the vast world of quantum computing. Here, tiny particles called qubits hold the potential to process information at a speed that makes our current computers look like they're crawling. With the ability to process multiple probabilities at once, these quantum computers could unlock unimaginable advancements in fields ranging from medicine to artificial intelligence. Or, consider the medical field where the principles of quantum physics are already in play. MRI scanners, for instance, rely on quantum properties to create detailed images of our bodies. By manipulating the spin of tiny particles, these machines can paint a vivid picture of what's happening inside us, aiding in the diagnosis and treatment of countless conditions. Then there's the world of lasers, which again owe their existence to the principles of quantum physics. These concentrated beams of light are created by exciting atoms to a higher energy level, causing them to emit photons. Lasers are used in everything from barcode scanners to eye surgery, and they could not exist without our understanding of quantum physics. And if we truly want to appreciate the power of these tiny particles, we need to look no further than our own sun. The sun operates through a process called nuclear fusion, where tiny particles known as protons collide, creating helium and releasing energy in the process. This energy, derived from quantum mechanics, is what gives life to our planet. So, while these particles may be beyond our perception, they are integral to our daily lives. They power our technology, aid in our health, and even provide the energy that sustains life on Earth. Though our understanding of these tiny particles continues to evolve, one thing is certain: they have a profound impact on our world, in ways we can barely begin to fathom.